All right, today we're diving into some tech that honestly sounds like it's straight out of a science fiction movie. It's called IMAS, the Internal Multi-Aileron System. And this thing, it's not just an upgrade, it's a complete rethink of how drones fly, giving them the power to work in the absolute worst conditions while staying practically invisible. So let's break down how it all works. So, this is the big question, right? How on earth do you build a machine that can fly with the precision of a surgeon right through the middle of a brutal storm while also being a total ghost to any and all enemy sensors? I mean, it sounds impossible, but this is the exact problem that engineers are solving. And the answer is, well, it's just fascinating. To really get why IMAS is such a massive leap forward, we first have to appreciate the brutal reality of a modern drone's mission. We're not talking about a casual flight from point A to B. We are talking about operating in environments that are actively and violently trying to knock it out of the sky. First off, there's the air itself. Just imagine trying to fly through these totally unpredictable, violent blasts of wind that can send even the most advanced aircraft tumbling in a heartbeat. For a drone that needs to hold a rock-steady aim, this kind of aerodynamic chaos is a constant, mission-ending threat. And then you've got the enemy you can't even see. The second a military UAV takes off, it's being painted by radar from all directions. Every single surface, every little edge, and especially every moving flap on its wings can bounce a signal right back to the enemy. It basically turns a billion-dollar piece of tech into a sitting duck. And in the middle of all this chaos, the drone has to perform with absolute surgical precision. Whether it's hovering perfectly still to watch something, pulling off a tricky low-speed maneuver, or firing a missile at the perfect split second, there is zero room for error. The stakes couldn't be higher. So how do you solve all of these problems at the same time? Well, the folks behind IMAS came up with a pretty radical idea. Instead of just trying to make the external flight controls better, they just got rid of them. They completely redesigned the concept of flight by moving all the important stuff inside the aircraft. Okay, so what is IMAS at its core? It's a super advanced control system that uses a bunch of small ailerons or control surfaces. But here's the twist. They're all located inside the drone's body. By shooting precise jets of air through these internal channels, the ailerons can steer the drone without any visible moving parts on the outside. But the real magic, the secret sauce, is the powerful AI that's coordinating all of them, making thousands of tiny adjustments every second to fight turbulence and keep the drone perfectly stable. And this chart just lays it out perfectly. Look on the left, that's your traditional plane. Big, external flaps. They create drag, they light up on radar screens, and they're easily damaged. Now look at the right. That's IMAS. The drone has a completely smooth, sleek profile. This setup slashes drag, massively shrinks its radar signature, and keeps all the delicate flight controls safely tucked away inside. It's a total game changer in aircraft design. Now, this internal system is a brilliant piece of mechanical engineering, no doubt. But the thing that truly unlocks its full potential is the brain behind it all, a seriously advanced AI co-pilot. This quote right here really gets to the heart of it. The system is a hybrid control framework. Basically, it's not just one AI, it's two different kinds of AI working together as a team. You've got Model Predictive Control, or MPC, which is all about playing it safe and sticking to the plan. And then you have Reinforcement Learning, or RL, which is all about thinking on its feet and adapting to new situations. Each one has a very specific job. And here's how that team works. First, you've got the safety pilot, the MPC. Think of this as the experienced, veteran pilot who knows the rulebook inside and out, always guaranteeing a stable flight. Then, at the same time, you've got the adaptive learner, the RL. This is like the quick-reacting co-pilot who has flown millions of hours in simulations and can come up with a creative solution to any problem in an instant. And finally, a supervisor AI blends their suggestions, always choosing the option that guarantees safety and stability. So you've got this incredible AI brain. But, a brain is pretty useless without senses, right? For the AMOS system to make these split-second life-or-death decisions, the drone needs to have an almost human-like awareness of its environment. It needs to literally feel the world around it. The way it does this is through something called an intelligent sensor fusion network. Now that's a mouthful, but the concept is actually pretty simple. It means it's constantly taking in data from dozens of different sensors all over the aircraft, and then fusing all that information together into one single, super detailed, real-time picture of everything that's happening. And just look at this sensor network. You've got the IMU, which is basically the drone's inner ear, telling it which way is up. The GNSS/RTK, think of it as super GPS, knows its location down to the centimeter. Then you've got sensors that can feel the air flowing over its skin, and even strain gauges that monitor the stress on the airframe itself. It even has optical sensors and LiDAR, essentially its eyes, for navigating in tight spots. All this data gets woven together to give that AI brain a perfect understanding of its world. Okay, so the drone can think and it can feel. Now let's get to the really wild part that turns it into a ghost. Its ability to become almost completely invisible to both the human eye and advanced technology. This system has a two-pronged attack for staying hidden. For visual stealth, its skin is covered in special LED tiles. Onboard cameras are constantly scanning the background, the clouds, the sky, the ground, and the system projects that image onto the drone itself, basically turning it into an aerial chameleon. Then for radar stealth, it uses special radar-absorbent materials that just soak up incoming radar signals like a sponge. You combine that with a body shape that's designed to deflect radar waves, and this thing becomes incredibly hard to spot. So when you put all of these pieces together, the internal flight controls, that brilliant AI brain, the incredible sensor network, and the advanced stealth, you don't just get a better drone. What you really get is a fundamental leap forward in what aerial robotics can even do. So what does all this tech actually mean out in the real world? It means a level of performance and toughness that was, until now, pretty much just a dream. The performance targets for this system really speak for themselves. Just look at these numbers. These are the goals for IMAS, and they're just astonishing. In heavy turbulence, it's designed to stay level within less than half a degree. When it's trying to hover, it can stay inside a 30-centimeter box. That's tiny. If it gets hit by a massive gust of wind, it's back under control in less than a second. And the big one, its radar signature is cut by 20 to 40%. These aren't just small improvements. They are massive, game-changing leaps. This final quote from the source material just puts it all in perspective. IMA isn't just another upgrade. It's a foundational innovation. It's the bedrock for the next generation of UAVs, giving them a level of toughness and survivability that's going to define the future of aerial missions. So that kind of leaves us with this one big thought. We've just looked at a machine that can learn from its environment, adapt on the fly, and practically vanish. It really makes you wonder, doesn't it? If this is what's possible today, what in the world comes next?